Picture an environment that would instantly boil human tissue. Now imagine it instantly freezing solid, being blasted by radiation and stripped of all oxygen. To us, it is an unlivable wasteland. But somewhere on Earth, a living creature is enduring those exact conditions right now. For decades, the consensus was that life required a very narrow set of parameters to exist: consistent sunlight, breathable oxygen, and moderate temperatures. But when researchers plunged into the planet's deepest, most toxic pockets, they found life operating on a different logic. These organisms thrive by bypassing the requirements we once thought were universal. We are counting down the 10 most resilient survivors on the planet. By ranking them according to the conditions they endure, we can see exactly how far biology can stretch before it fails. Number 10 is the giant Amphipod. At 7,000 meters down, the ocean is a pressurized vault of total darkness. Down here, organisms often exhibit deep-sea gigantism. Under the weight of several kilometers of water, these crustaceans grow to massive proportions compared to their microscopic relatives on the surface. At number 9, the Dumbo octopus navigates this lightless seafloor using ear-like fins to glide through the water, scavenging for small invertebrates in the silt. Number 8 is the Goblin shark. This lineage has hunted in the abyss for over 100 million years, remaining largely unchanged while the world above evolved. It hunts by using biological sensors in its snout to detect the faint electrical pulses of its prey. Once it senses a target, its jaw snaps forward to capture fish in total darkness. These physical adaptations solve the problem of darkness. But as the conditions become more extreme, survival requires organisms to alter their internal chemistry. Number 7 is the Antarctic icefish. In waters that hover near the freezing point, standard blood would thicken and form ice crystals, stopping the heart. This fish produces natural antifreeze proteins that circulate in its blood, which lacks red cells entirely. It relies on the high oxygen levels of the cold water to survive without the hemoglobin most vertebrates require. At the other extreme is number 6, the Pompeii worm. It lives attached to hydrothermal vents where the water can reach temperatures lethal to almost any other animal. The worm survives by hosting a thick layer of bacteria on its back. This microbial fleece acts as an insulator, absorbing the intense heat from the vent while the worm stays in slightly cooler water. Number 5, the Yeti crab, also uses bacteria. It grows its own food supply on its hairy claws, harvesting microbes in a world where photosynthesis is impossible. While these animals adapt to find food, the species further down the list have eliminated the traditional concept of eating altogether. At number 4, the giant tubeworm grows up to 2 meters long, despite having no mouth, no stomach, and no digestive tract. It uses chemosynthesis. Bacteria inside the worm take hydrogen sulfide, a gas toxic to humans, and convert it into energy that the worm absorbs directly into its tissue. Number 3 is the zombie worm, which specializes in a very specific food source, the skeletons of dead whales on the deep ocean floor. Lacking a mouth, it excretes acid to dissolve the bone, allowing its internal bacteria to process the nutrients stored inside the whale's marrow. At number 2, the Mariana snailfish lives 8,000 meters below the surface. The pressure here is over 1,000 times higher than at the surface, a force that would crush the cells of most organisms. The snailfish survives through a gelatinous body and unique cellular chemistry that prevents its membranes from being compressed by the weight of the trench. We have seen life adapt to heat, pressure, and toxic chemicals, but the top spot belongs to a creature that survives by simply pausing its life until the danger passes. Number 1 is the microscopic tardigrade. It represents the known limit of biological resilience. When faced with lethal environments, the tardigrade enters cryptobiosis. It expels almost all the water from its body and enters a dormant state where its metabolism effectively stops. In this state, it can endure boiling, freezing, total dehydration, and the vacuum of space, returning to life only when conditions become habitable again. The tardigrade demonstrates that life can survive long-term exposure to conditions that were once thought to be absolute biological barriers. These species expand the known map of where biology can function, proving that life does not require an Earth-like climate to persist. This evidence directly informs our search for life elsewhere, specifically in the frozen subsurface oceans of Jupiter's moon, Europa. The existence of tubeworms and snailfish on Earth suggests that the dark, high-pressure oceans of Saturn's moon, Enceladus, may be capable of supporting complex organisms. If our own planet is home to creatures that can survive the vacuum of space and the crushing weight of the trenches, we must consider what other impossible adaptations are waiting for us in the uncharted dark.
If you enjoyed this video, don't forget to like, subscribe, and turn on notifications. Join Beyond Unknown for more incredible mysteries of space and science.